So the formula is the famous trigonometric identity, which is, so the problem is to convert this into the other guy. And the thing which is going to do that, enable one to combine the sine and the cosine terms, is the famous formula that A times the cosine, I'm going to use theta because to make it as neutral as possible. So theta you can think of as being replaced by omega t in this particular application of the formula, but I'll just use a general angle theta, which doesn't suggest anything in particular. So the problem is you have something which is a combination with real coefficients of cosine and sine, and the important thing is that these numbers be the same. In practice, that means that the omega t, you're not allowed to have omega 1, you're not allowed to have omega 1t here and some other frequency, omega 2t here. That would correspond to using theta 1 here and theta 2 here, and though there is a formula for combining that, nobody remembers it, and it's, in general, less universally useful than the first. If you're going to memorize a formula and learn this one, it's best to start with the ones where the two are equal. That's the basic formula. The others are variations of it, but there's sizable variations. All right, so the answer is that this is equal to some other constant, real constant, times the cosine of omega theta. Theta minus phi. Of course, most people remember this vaguely. What they don't remember is what the c and the phi are, how to calculate them. I don't suggest you memorize the formulas for them, but you can if you wish. Instead, memorize the picture, which is much easier. Memorize that A and B are the two sides of a right triangle. Phi is the angle opposite the B side, and C is the length of the hypotenuse. Okay, that's worth putting up. I think that's a pink formula. It's even worth 2 of those, but I'll thrift. Now, let's apply it to this case to see that it gives the right answer. All right. So to use this formula, how will I use it? Well, I should I'll reproduce the left-hand side, so that part I just copy. And now how about the right? Well, the amplitude, it's combined into a single cosine term, whose amplitude is, well, the two sides of the right triangle are 1 and omega over k. The hypotenuse in that case is going to be, well, why don't we write it here? So we have 1 and omega over k. And here's phi. So the hypotenuse is going to be the square root of 1 plus omega over k squared. And that's going to be multiplied by the cosine of omega t minus this phase lag angle, phi. You can write, if you wish, phi equals the arctangent of, but you're not learning a lot by that.